Now let's continue. We have done the flag registers. We have done, hello, yeah, we have done the flag registers, right? Flag registers. And now moving forward to what we call as the have you ever heard that a microprocessor is an interrupt driven device? Anyone? People generally hear it. Interrupt driven device? Okay, let me tell you this important bit of microprocessor. Make it along what I'm making. Why are these lines coming in between? I'll kill them. Then we have this is interrupt controller. C means controller. You would not write whenever you are going to explain someone, don't write C or something ACC or TMP just or instruction R. Write it completely, because I'm not able to write by this pen so finely. That's why I'm writing like that. So you have to write interrupt controller completely. Interrupt controller. Now what you will do is, I'm not able to draw this completely, so I'll make a bigger box out here to represent this interrupt controller, right? And I'll write over it and then I'll rub it off, right? Now there are certain lines that you have to make. You have to write exactly like INTR, INTA or whatever I'm writing, right? Oh. This device is gonna kill me. Okay, you can laugh. Yeah. I wish I could laugh. Making has this software gone mad? I'm not doing anything. The faster I want to complete the course, the slower I have become. because of these idiotic devices. Okay, now it's working, thank God. RST 5.5, then RST, which ports are there in it? 6.5, RST 7.5, and there is a TRAP. This is P. You just understand it by yourself that it is P. I'm not able to write it out there. Now what is it? What do you mean by an interrupt controller? I told you that there are a lot of devices that are outside the microprocessor. I told you it is not a microcontroller. It is a, what is the difference between microprocessor and microcontroller? Good. Now a microcontroller, a microprocessor has to interact with a lot of devices. Maybe it can be input-output devices, it can be memory devices, it can be other synchronization devices, or a lot of different devices can be added to that. Now those devices, let's say Mr. Obama is there, right? Everyone in this room wants to meet him, right? To get a photograph. Okay. You don't want to. Okay, leave them aside. You want to meet, and you have to meet. That's my restriction. So you want to meet that person, and if I make him stand out here, then you all will come in front and try to get a chance to get a picture with him. Will you be able to get a single pic of just Obama and you, or Mr. X and you? Will you be able to? But a microprocessor cannot entertain all the things at a certain moment of time. Let's say you are going to a doctor. Let's say you are going to a doctor. Now when you are going to a doctor, is he sleeping? Yeah, better. So if you are going to a doctor, then do you just jump into the room and you say, hey, I'm having this problem, treat me or I'll kill you? Do you do this? No. There's a compounder or something like that outside, receptionist, who makes you say, hey, this is a slip, wait for some time, he'll attend to you shortly. So, right? This is how he does the thing. This is how he does. And the same thing happens with a microcontroller or a microprocessor. When there are a lot of devices that wants to use the microprocessor, because at the end of the day, when we want to transfer anything or we want to compute anything, it has to be done by microprocessor itself. So every device want to use the microprocessor, right? We always want to use the microprocessor, but microprocessor cannot interact with everyone at the same moment of time. That's the restriction. So we use this device that is called an interrupt controller. What happens is when you put a CD drive in, or when you do anything, or any device want to use when you use the CPU or the microprocessor, what it does is it sends an interrupt. It sends an interrupt to the interrupt controller that, hey, I want to use your services. I want to talk to you. I want to contact you. And the interrupt controller, what it does is, it actually recognizes that what kind of priority it is. What kind of priority does he has? If a doctor, let's say the Prime Minister comes and there are all other common man sitting out there, will he say, hey, Mr. Prime Minister, wait for some time, I'll treat to you shortly? Right? He'll not do like, he'll say, hey, please, come in. Right? So he will treat the Prime Minister by a different dignity. If a beggar comes to him, he treated with a totally different way, right? or if a normal patient comes, he treats him by a different way. So there are priorities to different devices that has to be given, and that priority has been given by the interrupt controller, and he decides that which device is going to use microprocessor firstly, or when is that device going to use the microprocessor, right? Now you might be, okay, this is a bit light. Can you see everything that I have written? INTR, INTA, RST 5.5, 6.5, 7.5 and TRAP. That is P, not TRAI, Telephone Regulatory Authority of India. That's not that. Right? That's trap. I'll tell you why is it called trap. That is a trap, actually a trap. Now what happens is, interrupt request, INTR is interrupt request, but whenever you write it, you will always write it INTR, because that's the symbol, right? Whenever you write INTR, it is INTR and not INTR request, never like that, INTR. So INTR is having the least priority in terms of, if you compare with any other device on the interrupt controller. Got it? When we compare it to other devices, the INTR is having the lowest priority. Then a bit higher to RST 5.5, a bit higher to RST 6.5, then a bit higher to 7.5. These are called maskable, write it down, maskable interrupts. What is it called? Maskable interrupts. What is it called? Correct. Now maskable interrupts means, what do you mean by maskable? Huh? Can be hidden. If I put a mask over him, maybe his identity would change or he would be hidden. Right? Masking means hiding or making the interrupt wait. So if these kind of interrupt come, interrupt request, INTR, RST 5.5, 6.5 and 7.5, then the microprocessor can say, hey, wait for some time. But if there are 4 requests that have been given to all these 4 different INTR, RST 5.5, 6.5 and 7.5, then whenever the microprocessor becomes free, whom will he treat it first? 7.5, because it is having the highest priority, right? RST 5.5 is having the highest priority as of for now, right? And 6.5 would be having a bit lower priority. 5.5 a bit more lower priority, and the least priority is given to INTR. Now trap is non-maskable interrupt. What is it? Non-maskable interrupt. What is it? Write it down. It is a very important term, maskable and non-maskable interrupt. If you go to your my computer and you open the devices, you go in devices and you open the properties, then there would be some devices that would be written maskable, and there would be some which are written non-maskable. If you see them closely, it would be written over them. So this trap, TRAP, is non-maskable. That means if there is a request over this one, over the trap, then the microprocessor would not make him wait. But it doesn't mean that it would not complete the current cycle. I told you an instruction cycle. Whenever it completes one instruction cycle, it will give the control next to trap. It would not stop that command in between. Right? Done? So trap is the highest priority interrupt, going lower to 7.5, 6.5, 5.5 and finally to INTR. Now what the hell is INTA? What do you mean by INTA? I told you, whenever your tummy is full after eating at someone's dinner party, you say, I am done. You give an acknowledgement. You tell them that yes, you are full now, I don't need anything more. You tell them, right? Whenever you get something, you say, okay, this is enough for me. You say like that, right? So whenever the interrupt controller gives the control of microprocessor to a device, it notifies that device, it gives an acknowledgement that yes, my friend, now it's your turn to use this device. You're good to go. Right? So int A is for acknowledgement. What is it for? Acknowledgement. Write it down. Shall I delete it? Shall I? Written, everybody? Shall we move forward? Now we will do one more device that is there in the microprocessor, and then we'll go for a break because it's 1:45 according to my watch, and their watch is going 5 minutes faster. Right? It's 1:45 or 1:50? Huh? Oh, I'm sorry. 12:45. So I'll leave you at 1, and we'll expect you at 2 o'clock. But another 10-15 minutes we'll study, and then after that I'll complete your microprocessor, then we'll go on to sensors, right? Acha, tell me one thing. What do you want to do? Because see, let me put the scenario in front of you. If we complete the microprocessor with if we complete microprocessor along with the sensors, then that would be done for the day. If we just do microprocessor and after that we do what we call some other components that you can make with transistors, then I don't know whether we'll be able to complete it, but yeah, we can definitely start it. So what do you want? Complete the microprocessor? Sensors? Done? So for today we'll be doing microprocessor and sensors, right? So now, the device for right now, the device for the day, or the hour I should say, huh? Not more than an hour or so. But if I'm doing sensors, then I will correlate it to the microprocessor. Then it would be easier for you to understand. So I would personally recommend that you do sensors, and it would be much more beneficial for you. And in any case, those oscillators and all, you can get in touch with me on Skype or on Facebook. It would be more preferable on Facebook. Do you know my name? You don't know my name? Okay, write it down. I am Diwakar, Diwakar, Vaish. All the robots, the posters that you have seen, I made all those robots. I have filed a lot of patents. I have made a lot of robots. All the robots that you have seen in VIT that I have bought, all those robots I have made, and I am still researching on different kind of robots. Now we are researching. Like I'm going forward in Mindwave. Mindwave. Do you know about Mindwave? How many of you don't know about Mindwaves? Raise your hands. Oh my God, a lot of you. Okay. So Mindwave is a device. I'll complete that device also. Don't worry. Not Diwakar Vaish. I'll complete the other device that I'm going to. So that is a device. That is a headset. If I wear it, I can just think and give that command. By just thinking, I can give the command to my robot to do anything. Anything. So we have succeeded in one or two commands that we do by like thinking. that if we relax, the robot relaxes. If we wake up, the robot starts up. So these are the two things that we have been able to do so far. And in coming time, we'll be able to understand everything. And that device is right now being used to analyze, because if I put it to your head, then I can get to know how much attention are you paying right now to what am I saying. And there is a meditation meter also, so that I can know what are the passive things that are going on in your head, that whether I have to meet my girlfriend in the evening or something like that. So I can know all those different things just by putting up that device on your head, and I can analyze all those things. So by that we are able to make the course syllabus for you much more easier and much more understandable. You must have seen that whatever we have taught, you would have found it pretty elementary, very easy to understand, right? So by all this research, we are able to make all those things pretty easy for you and very easy to understand. You must have studied resistors and capacitors in your school, have you? Was it that much easy? Was it? But now you have done a practical application of resistors and capacitor and even transistors. But did you find it difficult? Was it too difficult, I should say? For the first timers, it might be, but if you do it one or two more times, it would be easier for you guys. So we are actually doing a lot of research over that, and right now we are making this much big robot that is costing us somewhere around like 5.5 crore rupees. So we're spending a lot of money on research also. So you'll be able to see that robot next year in maybe March or April. That would be the most advanced humanoid robot till date. It is not American, not Japanese, not Korean, not German. It would be an Indian robot, completely Indian robot. So well, all those talks later. Let's come back to the device. We are left with 10 minutes. You can send me a request on FB if you want to, and if by chance you cannot send me a request, because I have 4,000 something friends, so the FB people, they are very scared of me, so they might not be giving you the opportunity to send a friend request. Leave that behind. Now there's a controller named writing it down. Shall I continue? सर जरा ये गेट बंद कर देंगे? Excuse me. तो गेट थोड़ा बंद कर. It's distracting me. Serial I/O controller. There are 2 points in it, SOD and SID. It's not CID, it's SID. It's SID and SOD. Now, what does this mean? SOD and SID. Where will it be drawn? Let me tell you. Don't draw it in a hurry. It would be out here. Right? It would be like this. And it would be like this. Right? Serial input-output controller. Now we know, have you drawn it? Now we know that the memory, the storage cannot directly interact with the ALU because it is, which one? Storage? Right. So storage is very slow, so it cannot directly interact with microprocessor or the ALU, right? So do you think when you type the things, when you type on the keyboard, then do you think that your speed is enough to match the speed of microprocessor? Then you have to write how many words approximately by today's standard, 10 raised to power 12 words per second. That would be the speed. Can you? Anyone? Right. The typing speed can be maybe 60, 70, 80, 90 words per minute, not more than that. Maybe 100, 150 also, some genius, but not more than that. So to make the microprocessor much more efficient when we are typing, we use this controller that is called serial input-output controller. What is it called? Serial input-output controller. What it does is that whenever we type something on keyboard, it is sent serially. What does that mean? What does the serial mean? It's not that saas bahu wala serial. It is serial means in a line, in a row. When we are talking about serial, then the data is transferred like this pen is, yeah. I was doing it deliberately, don't worry. So whenever we are sending a data by keyboard, that is in serial form. I didn't do that. So my pen is away from it, it's still moving. It is saying, leave me alone. You have tortured me a lot. Yeah, I'll not leave him. The data is sent from keyboard to microprocessor. What happens is the data is sent serially. Serially means 1 and 0 and 1 and 0, 1 and 0. It's transferred in a line. It's not transferred by what we call as bus. It is transferred by a line. So at a time 0 will go, then at a time 1 would go, then at a time something else, something else, something else, and something else. Because it is a very slow device. Right, so we do not need a very big bus. So what happens is, the serial input-output controller is having a small register in it, and whenever we are sending any input data, it stores, it buffers that data. What do you mean? Do you know the meaning of buffering? Buffering is storing temporarily. Storing temporarily, like when you store the water in your overhead tank, that is buffering water, for an example. That for further use, you are storing it because you might use it when it is not available by the main supply medium. Right? So that is buffering. So it buffers the data, the serial data, to 8-bit, because this is a 8-bit microprocessor. So it buffers the data, it buffers it until the 8 bits are full, and then slams it down to the microprocessor. Right? So what happens is that microprocessor would not need to wait for those bytes to come in serially. Correct? So, and then this is the work of SID. SID means serial input device, and SOD means serial. It means the data that is coming in, the device that can get the data slowly will get the data serially. Let's say there's only one transferring line, right? And there's not a bus, and the microcontroller needs to interact with that. So it will give the data serially. And whenever we are talking about a sensor, a lot of sensors are actually sending the data to SID or a serial input controller, input-output controller, because the data is not as fast. Maybe it can give 4 pulses in a second, means 4 data in a second. Maybe it can give 10, 20, 30, but it's nowhere matching near the speed of microcontroller, right? Or sometimes it can be directly given to data or address bus. I'll tell you what exactly data and address bus in just 2 minutes. At 2 o'clock, right? So got the work of SID or SOD done? Any doubts? Any doubts? Understood everything that I've taught? Every single thing? Any doubts that is there in your mind? Done? Okay guys, it's 1 o'clock as I promised you. Now meet you at 2 o'clock. Please be on time so that we can complete the course by 5 o'clock. Bye-bye. Have a nice day. Bye-bye.